Conical pendulum. A conical pendulum is a pendulum that sweeps out a circle rather than just back and forth. Since the pendulum bob is moving in a horizontal circle, we can study it as another example of uniform circular motion. However, it will prove necessary to decompose forces. Our first step is to draw a free body diagram and indicate the direction of the acceleration. We have mg down, force of tension along the string, and the acceleration is towards the center of our circle. This should remind you of the banked curve, but instead of normal force, we have force of tension. Then we will draw axes with one axis parallel to the acceleration, and then decompose forces so that all the components lie on an axis. In this case, we have to decompose the force of tension. So going up, we have force of tension times cosine theta because it is adjacent to our angle. And in the direction of our acceleration, we have force of tension times sine theta. Then we're going to solve for the acceleration by applying Newton's second law. So in the y-axis, we have t cosine theta minus mg equals 0. And in the x-axis, we have t sine theta equals ma. Again, this should look just like a banked curve without friction. Applying Newton's second law and solving for the velocity, we get the same equation we got when we did a banked curve with no friction. V is equal to the square root of gr times the tangent of theta. An alternative approach is to solve this as a vector equation using sigma f equals ma. Just translate the original vectors to form a right triangle so that the sum of the two forces equals a new vector, ma. I'm going to move mg up so they can be added in the tip-to-tail method. And then a vector sum is right here. And this is equal to ma. Since this is a right triangle, we can say that tangent of theta equals opposite over adjacent. Here is our theta. Opposite is ma, adjacent is mg. So we have tangent of theta equals ma over mg. Cancel out the m's and you get tangent equals a over g, or v squared over gr. And again, we get v equals the square root of gr tan theta. And to find tension, we can use Pythagorean theorem, a squared plus b squared equals c squared. So we get t squared equals mg squared plus mv squared over r squared.